So let's try to answer here, number 33. In an experiment, a voltmeter was connected across a terminal of a battery as shown in the diagram. So here's the battery, and then this is the voltmeter, and the current in the circuit is varied using the variable resistor. And so the graph shows the variation with current of the reading of the voltmeter. So the first question here is to calculate the internal resistance of a battery. So the first thing that we need to do is to identify two ordered pairs. I think this one is a good ordered pair. And what is this interval? Now, if you try to look at the interval here, we have 1, 2, 3, 4, and 5. So we're going to have 5 intervals, and that is 2 divided by 5. That would be 0.4. So each one, we're going to have a 0.4 interval. So this one is 0.4, 0.8, 3.2, and then 3.6. And so if we're going to look on this part, this one, it has a point of 8 and 2.4. Next, how about this point? This one, it has a graph of 2, and so this one is around 9.6. And so if we're gonna look for this, we're gonna we define the resistance as V over I. And that is simply the change in the voltage over the change in the current, and thus we're gonna define the resistance. And so continuing, that would be the value of the R, which is 2.4 minus 9.6 over 8 minus 2, and that is equal to negative 1.2 ohms. And so from here, we can take note now that the internal resistance of the battery is 1.2 ohms. And so next, we will calculate the EMF of a battery. So now, there's like two ways of calculating the EMF. If you try to look at the formula, we're gonna have the V is equals to E minus IR, or simply we're gonna have V equals to negative IR, or could have negative RI plus E. And so we can simply represent it in the form of Y equals to MX plus B. And so the M is the resistance, and for the I, that would be the value of your X, and for the E, that is your Y-intercept. So upon extending the line here, we can take note that somehow this will be equal to 12 volts. And so, well, temporarily, let's have our answer, which is 12 volts, but how we're gonna prove it mathematically? So first, get an ordered pair. So I will choose 8 and 2.4, and then this one will be the current, and the 2.4 is the voltage, and the slope, or the R, that is equivalent to 1.2. And so let's try now to substitute in the formula. So from here, we could have V plus IR equals to the value of the EMF of the battery. So from here, we transfer this to the other side, and that will become V plus IR equals to the EMF of the battery. And so the value of the value of the B, that is 2.4 plus the value of I, which is 8, times the value of the resistance is 1.2, and then this one will be equivalent to 1.2 times 8, that would be 9.6 plus 2.4, and therefore the value of the EMF, that would be 12 volts. And so the final answer here is simply 12 volts.